Alright, boys, I apologize for the late upload. I have just had a chance to get onto this booklet. Now, I'll first start with the introduction of the fractions. Ideally, we have seen fractions and we know what we are from primary school times, and many of you have already started fractions before joining our class. Essentially, the first thing we need to know about is what parts of fractions there are: numerator, vinculum, denominator. Essentially, numerator is what is being divided, vinculum is the representative of division, the denominator is what is doing the dividing. As an example, if I have one piece of cake divided by split amongst three people, I will only get 1/3 of the cake. That's the same thing. Now, this part of the exercise is just for us to shade equal size shapes and then what fraction of the shapes colored. In this example, it's 1 out of 3. In this case, 1, 2, 3, 4, 5 out of 8. Have a go at the rest of these. You guys should be able to do it. I didn't really put much emphasis into it. I don't really care. Same thing for this part. This should be an assumed knowledge for us accelerated class students, and that is fine. If you are fully unsure, you can come and ask me after. Now, this is where it gets really important, and this is where I would like to emphasize a lot. Equivalent fractions and simplifying fractions. Now, not all fractions are of different values. I could have 1/3 of the class are passing the exam, or I could say 20 out of 30 students are passing the exam. But it's the other way around. I said 1/3, so I should say 10 students out of 30. They are of equivalent fractions. That means they have equal value. If you remember when I did equivalent, or for the students who are new, I didn't explain it to you before, but hopefully that has been seen. So now, one of the best ways to, express an equivalent fraction would be multiplying the numerator and the denominator, or dividing the denominator and the numerator by the same number. So in this case, it says 3/5, it says times by 3. I'm not going to do 3/5 times 3. I'm going to do 3/5 times 3, and times 3 on the bottom and on the top. Now, for this case, I'm going to do 12/32, but both will be divided by 4, and they will end up with 3/what's 32 divided by 4? Should be 8, and that's my simplified. Now, this process of simplifying fractions is what we just like to get rid of the common factors from both the numerator and the denominator, and until we cannot have any more common denominators, we don't consider it fully simplified. Okay? Now, 3/9 have common denominators of 3. That means I can divide both of them by 3, which will be 1/3. Another way to think about it, if you wish to take your time, you can do 3/9 divided by 3 from both sides, but you must do it on both sides because it will just change the value. This one, 18/24, sometimes you might not be sure. You could take it as a trial and error. I could divide by 2 from both of these numbers, just as a trial. 9/12. I can still divide them by 3/4. Now I'm done. Another way is if you can just do it, you can realize 18 is divisible by 6, 24 is divisible by 6, they're both divisible by 6. Have a go at these exercises, and all should be well. I'll just have a go at a couple of these examples for you to be aware of, okay? Simplify these fractions by dividing the numerator and numerator by the highest common factor. 16/20, I can notice it's divisible by 4. So it's 4/5. Our fractions 14/21 and 16/24 from question 4, equivalent fractions. Briefly explain your answer. Well, let's see. 14/21 can be divided by 7 for both numbers. So it's going to be 2/3. Let's see. 16/24, I can see that it divides by 8, which will be 2/3. Yes, because they both simplify to 2/3. I hope this is making good sense. Now, the second bit is improper fractions and mixed numerals. Hopefully we have seen it before, but the word improper fraction by definition just means, oh, my numerator is bigger than the denominator. This is improper because 3 is bigger than 2. Similarly, 5 is bigger than 4, that means it's improper. We use this symbol, means greater than, this means less than. Okay, but it's a little fun fact, don't worry about it. Okay, anyhow, mixed numerals have a whole number and a proper fraction. This means 1.5 or 1.25 or 15 and 7/9 or anything that works will be fine. Okay, now sometimes I will need to convert improper fractions into mixed numerals. This means I need to notice 5/3 is the same as 3/3 plus 2/3. Hopefully you remember that. Okay, adding fractions. This is the same as 3/3 is 1 plus 2/3, which is 1 2/3. For me, I do not like to do this once I get comfortable. I like to think of how many 3's fit into 5. Well, 5 divided by 3 is 1 remainder 2. That's exactly what's going to happen here. 1 whole and then 2 remainder. Let's think about this. 14/4. I'm going to give you guys 10 seconds to think about it. I have 14/4. I would like to simplify this into mixed numerals. How many times does 4 go into 14? Or better yet, what can I actually do to make it easier? I notice the common factor between the two numbers. 14 and 4 can both be divided by 2. 7/2. Now, at this point, I don't have any more common factors left. I'm going to now try to convert them into mixed numerals. How many times can 2 fit into 7? Well, 6 times 3 is 6. 2 times 3 is 6. And then any more than that will be beyond 7. So it will be 3 times 2 will be 6. And then 1 remainder over 2. Essentially, we're trying to do a short division from primary school, trying to do 7 divided by 2, 3 remainder 1. Okay? The other way I personally like to see it as an easier option, mixed numerals into improper fractions. This means 1 2/3 is the same as 1 plus 2/3, which is the same as 3/3 plus 2/3. Now, the reason why I converted 1 into 3/3 is because I want it to be the same as the denominator here. So I just say 3 over here too. So it's going to be 5/3. They're different denominators. Now, easier way for me, again, I'm going to tell you the easy way. How many 3's is in 1? I'm not wording that right. I'm going to do 1 times 3, and then that will be added as the thirds that add on to 2. So it's going to be 3 plus 2/3. Similarly, I do 2 times 5, which is 2 times 5, and then I do the normal plus 1/5, which should be 10 plus 1/5, which is 11/5. Okay? Have a go at the rest of these pages. I'll go through a couple of these examples. Okay, let's have a look at question B. 14/3. Let's see, how many 3's fit into 14? I know a multiple of 3 that is 12. If I go any more than that, it will be 15, which is too big for 14. So I'm going to say, 3 times what is 12? 4. And then what's the remainder? 2/3. All good? Now these ones, we wish to simplify them first and then change them to mixed numerals. This means I'm going to try to find the common factor first. Okay, 3, 5/3. Now how many times does 3 fit into 5? Once, and then 2 remainder. So we say 1 2/3. Now let's be smart about this. Next one, question C, because I'll do the hardest one for you. 4 times 5 will be 4 times 5 here, and then I do the plus 4, so plus 4, all divided by 5, because that's how many fifths are in a 4. So 20 plus 4/5, or 24 over 5. Write the equivalent improper fraction for these mixed numerals after first simplifying the fraction parts. Now, I'm going to have a go at question C, the hardest one. I would like you guys to try A and B after pausing the video, but I'm going to come back to doing C, okay? All right, have you guys unpaused the video? Thanks for the unpause, okay? I'm going to start by finishing it up. 24 over 72. These are both challenging numbers, okay? If you can't do it at once, that's fine. I personally can see it, but take it one step at a time. Divide by 2 first. 12 over 36. Okay. 25. I can see 12 and 36 can both be divided by 6. 2 over 6. As a matter of fact, they can both still be divided by 2, which is 1/3. 25 and 1/3. Now I turn them into improper fraction, which means 25 times 3 plus 1 over 3, which is 76 over 3. Okay? Number line, I'm not really worried about it, so we'll just go ahead, skip it. Comparing fractions is one of the key things we will be assessed on in the upcoming test. Sometimes we need to figure out if half is greater than a third, which in our case we should already know. We should always try to change the denominators into the lowest common multiple. So essentially we want them to look the same. As an example, 2/3, 3/4, and 5/12 are confusing for me. I have no idea how they're going to look. And I have no idea which one's bigger or smaller. What I'm going to do is I'm going to make the denominators look the same. 3, 4, and 12, the lowest common multiple is 12. This means the 2/3 need to be multiplied by 4 and 4. The 3/4 need to be multiplied by 3 and 3. And the 5 on 12 is just good as it is. This will be 8 on 12, 9 on 12, 5 on 12. 5 on 12 was the smallest. So now, that's not it. Once I have turned them into the same denominators, I'm not actually answering the question yet. They said, compare the size of these fractions. 9 over 12 is the biggest. That means 3/4 is the biggest. I say 3/4 is greater than, what comes next? 2/3, because that's that one, which is greater than 5/12. If you don't write this, you're not answering the question. They said compare the size of these fractions, answer it as such. Okay? Question II. I'll give you guys a second to pause and have a go. Unpause when you're done. Okay, I'm going to go straight into it. You should have paused and tried by now. 4 and 5 has a lowest common multiple of 20, so 11 over 4 times 5 times 5, 13 over 5 times 4 times 4, 55 over 20, and 52 over 20, which means that's bigger. Therefore, 11 over 4 is greater than 13 over 5. Okay? Hopefully all is well. Have a go at these. You shouldn't have a problem with these. Adding and subtracting fractions, these should be fine. Now, if I have 1/4 and 2/4, I add them, it will be 3/4. If I were to just say verbally, if I have 1/3 and I add another third, I would have 2/3, right? Linguistically, it makes sense. That means this other fella, all of these other fractions work the same as long as they have the same denominators. If they do not, that's a problem. We wish to convert them into same denominator of equivalent fractions. So we need to actually revert them back to less simplified versions and find the lowest common multiple. As an example, 2 over 9 plus 5 over 9 is same denominator, so 9 stays the same, 7. 6 over 7 minus 2 over 7 is just over 7, but 4, all is well. 2 over 3 plus 5 over 3 is, I am kidding, it's not 8. I was joking, if you knew. Now what happens here? I have to simplify it, right? This turns into 2 and 1/3. Now look at this question. 2/3 plus 1/5, it's the same as, it's the same as trying to do 2 over 3 times 5 times 5 plus 1/5 times 3, which is 10 over 15 plus 3 over 15. Okay? Have a go at these. Unfortunately, due to time, I cannot do all of these for you. These are quite explicit. I'll have a go at the hardest question here. Let's see, which one's the hardest? Oh, question F. I'll do one easy one, I'll do one hard one, okay? 3, 4, and 6, they're all different denominators. I don't want that. I want them to look the same. What's the lowest common multiple? 12. 3, 4, and 6 has the lowest common multiple of 12. So that means I get 2 over 3, but multiplied by 4, and minus 1/4, but multiplied by 3, and then plus 5 over 6, but multiplied by, you got it, 2. I'm guessing you guys thought that, okay? 8 over 12 minus 3 over 12 plus 10 over 12, which is the same as 15 over 12, which is the same as 5 over 4, which is the same as 1 1/4. Okay? You simplify first and all should be well. Once you have gotten to this point. Don't simplify here because that's what you brought up to. Now, 12, 3, and 24. That's fine if you're not fully sure. The lowest common multiple is 24. 7 over 12 times 2 minus 1/3 times 8 plus 11 on 24 times what? 1. It's just by itself. 14 over 24 minus 8 over 24 plus 11 over 24, which is the same as, it's so easy. What is it? What's 14 minus 8? 6 plus 17 over 24. And that's it. Okay? Have a go at all these. Now, one of the things about these, adding a whole number, you can do another thing. You can say, 3 1/4 is 3 1/4, quite literally. This one can be a bit confusing. 1 2/5, you need to find another way to express it, because subtraction, I can't just put it next to the number. Unlike this guy. This guy's a nice one. Not X. This guy's a nice one. Happy face. But this is a sad face. Okay? Makes me angry. So 1 minus 2/5 is the same as 5 over 5 minus 2 over 5. Because 5 over 5 is 1. That's now 3 over 5. 4 minus 2/7 is the same as, what's 4? How many 7th is 4? 4 times 7 over 7 minus 2 over 7, which is the same as 28 over 7 minus 2 over 7. This is 4. So you get 26 over 7. Now, ideally, for now, year 7 and 8, try to turn them into mixed fractions, mixed numerals, but later on I'll teach you to not worry too much about it. So 3 and 5 over 7. Okay? Have a go at these. Multiplying and dividing is actually one of the simpler ones. If you're multiplying the fractions, numerators by numerators, so 1 times 2, and then denominators by denominators, 3 over 5, and all that, 2 over 15. And simplify as much as you can if you find something. Division, I like to call this KFC method, because I love KFC, and I don't care. I love it. I have 1/3 divided by 2 and 5. I keep the first one, flip the second one. Reciprocate is the word that I like to use, and my normal class knows it. And I change the division into times, so change. If you say KCF, I don't care. I'm not going to listen to you. It's KFC. I like KFC. Now I simplify from there. It's 5 over 6, and the answer is there. Okay? Now, do not do the shading blocks. This is not necessary anymore because I was only doing this as a geometrical proof of how to multiply fractions. But in a procedural sense, it's not really necessary. We do not have to worry about it. You can actually just do 1/5 of 3/4, which is 3 over 20. Just times the numerator by numerator and the denominator by denominator. All should be well. 3 over 4 times 7 over 9 is the same as 21 over 36. And you can divide it by 3. Okay, have a go at these. Now, 2 on 3 squared is the same as 2 on 3 times 2 on 3, as it says on the hint, 4 over 9. Same thing for question D. Question E, oh, there's a division. What should I do? Right, KFC, sure. Keep the first one, flip the second one, change it to times. 2 over 9. Okay? But Mr. Kim, what about question G? How do I flip a number 4? Well, if you think about it, 5 over 6 divided by 4 is the same as 4 over 1. I like to think of it that way. So now 5 over 6 divided by 4 over 1 is the same as times by 1 over 4, which is 5 over 24. All good? Better be all good. Spending my Friday night on this. Yeah. Now, operations with mixed numerals. I'm just going to deal with them all together. It's a problem-solving question. One of the key important things to remember, ideally you write this in your booklets, always improper. Improper is probably the best way to go about it. Okay, the questions, these are telling you to use the numbers by themselves first, but I do not like it because sometimes students mix it up for the other questions. So, screw this. I should have actually erased it myself, but I ran out of time, unfortunately, at the start of the term. We always turn it into improper and we just do it. Okay, as an example, I changed this into 1 and 2/3 is the same as 5 on 3. You may pause the video for you to try yourselves if you're not fully sure. I'm just doing it in my head really quickly. I apologize. 10 over 6 plus 13 over 6. This is the same as 23 over 6. And then you simplify to mixed numeral, which is the same as 3 and 5 over 6, I think. Yep. Now, this one is the same. You get 21 over 5. Again, I did it in my head. I apologize. I do not have time. It is what it is. If you wish, you can ask me in class. Yep. And then there's going to be 42 over 10 minus 15 over 10. That's the same as, oh, I can't do this that fast in my head. 2 and 7/10. Okay? If you wish to digest it, have a go at yourselves. Okay? Multiplication and division is all the same. 1 and 3/4 is the same as 7 over 4 times 2 and 1/3 is the same as 7 over 3. You times it 49 over 12. And then simplify it to mixed numeral as you wish. It's going to be 4 and 1/12. Division is the same thing. 7 over 6 divided by 2 on 1. KFC 7 over 6 times 1 on 2, which is 7 over 2 times 6, which is 12. Okay? All right. Have a go at the next bits. Do it. I'll go through some of these questions, combining all the operations. 1 over 7 plus 6, 3 on 5 times 1.5. I have taught my accelerated students to do the working out as much as they can. I hope you guys can also get into it as well. I have no idea what just happened. Okay, I'm back. 1 over 7 plus 6 and 3. Oh, there's so much stuff going on. Take one step at a time. Don't be afraid of rewriting the questions. 1 over 7 plus 6 and 3/5 is the same as 6 times 5 plus 3 over 5. Times 1 and 1/2 is 3 on 2. So notice how I'm just rewriting the same thing as long as I have everything cleared out. Doesn't matter, just keep doing it. Now, at this point, 1/7 plus 33 over 5 times 3 on 2, which one comes first? BODMAS. This guy. Right? So 1/7 just keeps following. It's tagging along. Okay? Plus 33 times 3 is 99 over 10. So now I have 1 over 7 plus 99 over 10, which is the same as 10 over 70 plus 99 times 7 is the same as 697, I think. Oh, 693 over 70. Okay, and then now I get 703 over 70. All good? Have a go at the next one. This is left to right. So division first. Now, problem-solving questions. I believe this is the last few that we've actually gone to for the mainstream class, our original class as well. If I were to ever say I have two of my friends and blah, 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 this means I have two friends that I'm talking about, right? Doesn't mean I only have two friends. I might have more or less. I don't know. But if I say two of my friends, I'm talking about two friends. If I say two of my buddies or half of something, I'm always talking about the proportional thinking. If I say 2/5 of a chain from 20, it means 2/5 of 20, which always just happens to be just multiplication. In mathematics, of means times. Okay? Half of my friends means half times whatever the number of friends I have. Half of the class of 30 means half times 30, which is 15. Okay? And then we just do the maths as we go. So as an example, Juliet lost 1/4 of the 116 songs she had downloaded when the computer virus infected the files. How many songs were not affected by the virus? Well, 1/4 was affected. That means 3/4 not affected, right? So I do 3/4 of 116, which is 3/4 times 116, which is so easy, right? We can definitely do this in our heads. What is that? That's 29 times 3. Is that 87? I don't know. My brain is really slow, guys. I'm tired. It's 9:46. Okay. Now, how long is 7/10 of an hour? Well, I can't really mess with hours. Okay. I'm not really good at it. By the way, check with your calculator or something. Okay. I'm not really, my brain's really sleepy. Okay. Don't worry about it. 7/10 of an hour. I don't like to deal with an hour because that's confusing. If I get any smaller than 1, that's decimal. I don't like it. So I say, all right, 7/10 of 60 minutes. How's that? And here's a little cool maneuver. If I have 7/10 times 60, this is the same as 7 divided by 10 times 60, right? They can actually kind of go together and then cancel out what we can. So 10 and 60 cancels out to be 6. So we end up getting 7 times 6, which is 42 minutes. So 70% of an hour, or 7/10 of an hour, is 42 minutes. Okay? So as an example, 1/5 of 20 is the same as 1/5 times 20 on 1, which is the same as 20 on 5. Or another way to think about it is 1/5 of 20 is just 20 divided by 5. Okay? And then 20 over 5 is 4. 2.5 of quarter is the same as 5 on 2 times 4, which is 20 over 2, which is 10. Or another way you could have done is 2 and 4 cancels out to be leaving 2. And then if you did that, it would also have been 10, which is the same thing. There's so many ways to do this in maths. Have a go at all of these, okay? If you have any questions, just feel free to ask me on Google Classroom, okay? Just have a go. And I'll go through a couple of these questions, but let's see. Krista and her teammates each receive 1/5 of a $900 prize. How much does Krista receive? 1/5 times 900, which is the same as 900 divided by 5, which is so easy. Okay? Give me just 1 second for me to do this in my head. I can't do this. $180, I think. Yep. If I got it wrong, that's fine. I'll take it. I'll accept it. Okay? I can make mistakes. I'm an old man. Okay? Let's go into the second bit. Let's see. Two amounts as a fraction. Sometimes, most importantly in your exams, you get something that's like this. Oh, I got 24 out of 40 in my exam. I wonder what percentage this might be, or what fraction this might be. Well, if I got 24 out of 40 marks, this is the same as 24 over 40 as a simplified. This is the same as 6 over 10. This means I got 60%. If I were to compare two amounts, I can just write that as a fraction of another. That's the idea of what a fraction is, actually. A quantity in comparison to another quantity. Okay? So if I get 14 out of 36, it's the same as 7 over 18. All the boxes in the picture weigh a total of 40 kilograms. The box being carried is 2,000 grams. Oh, keyword, right? What fraction of the total weight is being carried? This 2,000 grams is the same as 2 kilograms. Why did I have to convert it? Because they have to go to the same units. If I did 2,000 grams over 40, this would have been very incorrect. Either I do 2,000 grams over 40,000 grams, or I do 2 kilograms over 40 kilograms, but smaller ones are always easier, right? 2 kg over 40 kg. This means I am carrying 1/20th of the weight. Okay. What fraction of 2.5 hours is 15 minutes? It's the same as 2 hours and 30 minutes and 15 minutes. Let's compare the quantities, yes? Minutes or hours. Personally, I'll show you the minutes method, but in class I showed an hours method as well, but that's a harder one. I'll see if you guys get comfortable with it. 2 hours and 30 minutes is the same as 150 minutes. Yes, so that means I have 15 minutes over 150 minutes, which is 1/10 of the time. Okay. Have a go at these, and we're done. If you have any more questions, please feel free to ask.